Good morning, dear students. Today we'll study the second chapter, that is DC voltage regulators. It is from second model, that is active filters. So voltage regulator. So voltage regulators is nothing but circuit which keeps the output voltage as constant. If any changes in the load current and input voltage, the output will remain constant. It is known as voltage regulators. So it is having its input as unregulated pulsating DC voltage obtained from filter and rectifier, and its output is constant DC voltage, which is almost ripple free. So this is a block diagram of regulated power supply, which is consisting the various stages, that is transformer, rectifier circuit, filter circuit and regulator circuits. So the AC voltage 230 volt 50 Hertz is connected to the primary of the transformer. The transformer steps down the AC voltage. With the suitable turns ratio, we'll get the desired AC secondary voltage. Then the rectifier circuit, as we know, the rectifier circuit which will converts the AC into DC voltage. Here it is converting the AC into pulsating DC voltage. So pulsating DC voltage, it means it is a unidirectional voltage which is containing a large varying components and which is containing a ripples. So after the rectifier circuit, the filter circuit is used, where the filter circuit will reduce the ripple content in the pulsating DC and it tries to make the smoother. Still then the filter output contains some ripple. So this is called as unregulated DC voltage. So you can see this waveform. This is unregulated DC voltage. Regulator circuits, which not only makes the DC voltage smooth and almost ripple free, it also keeps the DC output voltage as constant, though the input DC voltage varies under certain conditions. And it keeps the output voltage constant under variable load conditions. So it is known as DC supply, to which the load can be connected. So next is power supply performance parameters. Overall power supply is judged by specifying some parameters. So let's see in details various power supplies performance parameters. So first one is load regulation. So under the load regulation, when the load current is changed, from minimum load to maximum load, that is no load to full load, the load rejection is the change in the regulated output voltage. So this is a characteristics of load regulation. As the load increases, the load voltage will decreases, and ideally it is zero. Ideally the load will be zero. As we increase the load voltage will be decrease. So mathematically load regulation will be represented as, that is LR is equals to VNL minus VFL. So VNL is nothing but load voltage with no load current. VFL is nothing but load voltage with full load current. Then the percentage of LR, that is VNL minus VFL divided by VFL into 100. So next is line regulation or source regulation. So line regulation also will call that as source regulation, and it is denoted as SR. So SR is nothing but it is a change in the regulated load voltage for specified range of line voltage, that is 230 volt for plus or minus 10%. So it is represented mathematically as SR is equals to VHL minus VLL. VHL is nothing but load voltage with high line voltage. VLL is nothing but load voltage with low line voltage. Then the percentage of source regulation, that is percentage of SR is equals to SR divided by V norm into 100, where V norm is nothing but nominal load voltage. Next is output resistance. In output resistance, we'll understand the effect of output resistance on the load voltage. When load is not connected, when the load is not connected, the IL is 0 and the load voltage is equal to no load voltage, that is VNL. So VL is equal to VNL. But when we apply the certain load resistance, then VL is equals to V out is equals to VNL minus IL into R out. Ideally, the power supply R out must be 0 and V out must be equal to VNL. Power supply, practically the output resistance of power supply is very small and it can be supplied for different loads with a constant load voltages. So this is the characteristics of load regulation. As we know, if we applied any load, then the load voltage will get decrease. As the load increases, the load voltage will get decreases. Then the output resistance R out, that is equals to change in the V out divided by change in the load current, by assuming the input voltage and temperature as constant. So this is the output resistance. Next is voltage stability factor. So stability is nothing but it is a maintaining stable. So that is defined as there is a change in the output voltage to change in the input voltage, assuming the load current, and the temperature constant. Next is we have to stable the temperature, that is temperature stability factor, that is denoted as ST. ST is equals to change in the output voltage to change in the temperature by assuming the input voltage and load current constant. So next is ripple rejection. So ripple rejection is nothing but ripple content in the output to the ripple content in the input. It is called as ripple rejection. So ripple is nothing but disturbance or else undesirable signals. So ripple rejection unit is decibel, that is dB. So the R into R dash is equals to 20 log base to the 10 ripple rejection, that is unit is dB. So based on these power supplies circuits, we'll solve some problems. In that, first one is a voltage regulator data sheet includes a load regulation of the regulator as 3 millivolt while its maximum load voltage is 15 volt. Calculate its percentage load regulation. So we have to calculate the LR. So they have given us LR as 3 millivolt and VNL as 15 volt. So as we know, the LR is equals to VNL minus VFL. Calculate for VFL, you will get it as 14.997 volt. So the percentage of LR, that is VNL minus VFL divided by VFL into 100. Put the values of VNL and VFL. You will get it as LR as 0.02%. So next is, for a particular power supply, the load voltage is 10 volt plus or minus 0.3 volt for a line voltage of 230 volt plus or minus 10%. Calculate the source regulation and percentage source regulation. So they have told to calculate the source regulation and percentage source regulation, that is SR. So first, to calculate the SR, we need to know the VHL and VLL values. So that is 10 volt plus or minus 3 volt they have given. So that is 10 plus 0.3, you will get it as 10.3 as VHL, and VLL is equals to 10 minus 0.3, that is 9.7 volt. To calculate the SR, you know the value of VHL and VLL. Put the values of VHL and VLL, you will get it as 0.6 volt. So SR value is 0.6 volt. So now V norm, that is, already we know the V norm is nothing but it is a nominal load voltage. So V norm they have given as 10 volt. So percentage of SR is equals to SR divided by V norm into 100. So SR value is 0.6 volt. So V norm is 10 into 100. You will get it as 6%. So next is, for a series regulator, the input ripple is 1 volt peak to peak if the factor A plus B is designed as 50. What is the output ripple and ripple rejection in dB? So they have given as VR of in is equals to 1 voltage, that is peak to peak voltage. To calculate the VR out, that is VR in divided by 1 plus AB. So VR in value is 1 volt, 1 plus AB as designed as 50. So 1 plus AB value is 50. Put the VR in and 1 plus AB value, you will get it as 20 millivolt peak to peak. Next is ripple rejection. So to calculate the ripple rejection, we have to know the ripple content in output, that is VR out, and ripple content in input, that is VR in. So ripple content of output is VR out is 20 millivolt, that is 20 into 10 raised to minus 3, and VR in, that is ripple content in the input, it is 1. So the ripple rejection is 20 into 10 raised to minus 3. Then R into R dash. Formula is R into R dash is equals to 20 log to the base 10 RR dB. So 20 log into 20 into 10 raised to minus 3. You will get it as minus 33.98 dB. The conversion of dB values we have already studied in the first module. So this is a homework problem. Solve this problem. You may get this problem in quiz. Today's quiz, you may get this problem. If you get this problem, if you get this problem in the quiz, you have to upload your scan copy. So in the next session, we'll study the next part. Thank you.